Hi everyone. In this section, we're going to study the mean value theorem and Rolle's theorem. So I would like to begin to review the intermediate value theorem. The intermediate value theorem says if a function is a continuous on a closed interval ab, and where the function value at a and the function value at b are not equal, and for any y value capital M before f of a and f of b, then the conclusion is we can find at least a point C. We can find at least a number C between A and B such that the function value at that number C equals capital M. So what does this theorem mean? Is um, if we have a function whose graph is a continuous. Remember we said continuous means the graph has no break. In other words, uh, if we draw the graph with a pencil, then we can finish the graphing without lifting our pen, right? If the graph has a break, then this is not continuous. Okay, now we have this function fx is a continuous, and it's continuous on this closed interval from a to b, and the function value at a is this, and function value at b is this. They are not equal. Okay, now if these are true, for any number, for any y value between f of a and f of b, for example, here I call this as a capital M. Okay, so I can find a number between a and b on the x-axis such that the function value at c gonna be equal to this number. So what does this graph show is we can find that number over here. Right. So at this number, f of c gonna be equal to capital M, right? Okay, so this is what does intermediate value theorem tell us. All right, let's take a look at the mean value theorem. The mean value theorem says, suppose function is a continuous on a closed interval AB and differentiable on the open interval AB. Then there exists a point C in AB such that the derivative at this point, f prime of C, gonna be equal to f of B minus f of A over B minus A. So this says if the function satisfies this condition, then we can find a number between a, b such that the derivative of that number gonna be equal to the ratio of the difference of the function value at the endpoints a and b to the difference of these two numbers a and b. Okay, before I explain how to understand this theorem by using a graph, let's compare these two theorems and to see what do they have um, in common. Okay, what do they have in common? So both of them require the function to be continuous on a closed interval, right? And for the mean value theorem, it also requires the function to be differentiable. Okay, differentiable. Remember, we said differentiable means the derivative exists everywhere on this open interval. That means um, on this open interval from A to B, at every point on the curve, we are able to find the slope of the tangent line. Okay, we're able to find the slope of the tangent line. And this means the graph should have no corner or should have no a sharp point like this. If the graph looks like this. Now this is only continuous. It is not differentiable because at this point, at this number, the derivative is undefined. Okay. Okay. So right now we know the function is continuous and differentiable on AB. When x equals a, the function value is f of a, which is here. When x equals b, the function value is f of b, which is here. Now, if I connect these 2 points, I will have a red straight line, right? I will have a second line. Okay, now let me tell you this. On this curve, I can find a point, and at that point, I will able to draw a tangent line, and that tangent line gonna be parallel to this red line. Okay, can we do that? Yes, we can, right? Let me give you a few seconds to think about by yourself on which point we can draw that straight line. Remember, we wanted that straight line to be parallel to this red line. Okay. Have you decided your answer? Yeah, looks like it's somewhere here. Right. Mm, okay. Okay. So if I draw at this point, if I draw a tangent line, and that tangent line will be parallel to this red line. Okay. Now, what does this to do with our result? Okay. Let's think about first. If these 2 straight lines they are parallel. Now in pre-calculus we said if 2 straight lines are parallel, their slopes are the same, right? Okay, so let's take a look at what is the slope of each straight line. For this second line, how do we find the slope? Okay, so at this point, the x coordinate is a, and y coordinate is f of a. And at this point, the x coordinate is b, and the y coordinate is f of b. Using what we learned in pre-calculus, we can find the slope of this second line, which equals f of b minus f of a over b minus a. Okay, now for this tangent line, let's call the x value of this point as a c. Okay, so in calculus, we know that the slope of this tangent line we can write as the derivative of the function at this number f prime of c. Now, since these two straight lines they have the same slope, therefore f prime of c equals f b minus f a over b minus a. Okay, so this is what does the mean value theorem tells us. Okay, it tells us if the function satisfies these two conditions, one is a continuous on the closed interval, and one is a differentiable on the open interval, then we will be able to find at least a point. Okay, and at that point, the tangent line is a parallel to the second line between these 2 points, and in other words, the slope they have the same slope. Okay. Okay. So after I introduced what is a mean value theorem and reviewed the intermediate value theorem, now I would like you to think about which theorem should we use to solve this problem. Okay. Now this problem asks us to show that the following function has a zero on the given interval. Okay. The right theorem we should use is the intermediate value theorem. Why? Because to show that the function has a zero, all we need to do is to show that the graph of this function it passes the x axis between 0 and 5, right? Because if the graph intersect with the x-axis, then this x-intercept will be the 0, right? Okay, so how can we show that? So to show this, we evaluate the function at these two endpoints. If one of them is positive, another is a negative, then the function must pass the x-axis because this function is a continuous. So if these 2 points they are connected, and so the function, so the graph must the graph has to pass the x-axis. Now, when x equals 0, the function value is positive 2, okay, which is positive. And when x equals 5, the function value is well, I think okay, I think I might have a typo here. This should be minus 2. And when x equals 5, this is 5 squared plus 6 times 5 minus 2, which is 55 minus 2, which is 53, which is positive. So this turns out that when x equals 5, the function value is a positive number, and when x equals 0, the function value is a negative number. Okay. So if these 2 points are if we want to connect these 2 points, then the graph has to pass the x-axis. So therefore, we can show that the function has at least a 0 on the given interval from 0 to 5. Now, if the 2 points are connected in this way, then we have 3 zeros, right? If they are connected by just like this way, then there's only 1 0. Okay, but this doesn't matter because we are asked to show there exists at least 1 0. Okay, so this is the difference between the intermediate value theorem and the mean value theorem. In the next video, I want to show you a special case of the mean value theorem, which is a Rolle's theorem.